Now we're going to talk a little bit about formulas for measurement. We're going to use these a little bit in this class, but don't despair. Don't worry. We are not going to spend too much time on formulas in this class. I just want to give you a bit of a foundation so you are articulate in this area and you're also able to do the assignment for this week. So the very first thing we're going to talk about is current. Current is the count of the number of electrons flowing through a circuit. It is directly proportional to any voltage that is applied, and it's inversely proportional to resistance. You see it reflected in the equation above, where I, which represents current, is equal to voltage divided by resistance. An ampere is the unit to measure electric current. 1 ampere, or amp, is the amount of current produced by a force of 1 volt acting through the resistance of 1 ohm. Voltage. A volt is the unit of electrical potential difference, or essentially the size of force that sends the electrons through a circuit. Just think of it as pressure. It is the electromotive force. 1 volt is force required to produce the current of 1 amp through the resistance of 1 ohm. Resistance. Resistance measures the hindrance or the impedance on the flow of electricity. 1 ohm is the resistance of a circuit in which 1 volt produces the current of 1 amp. It depends entirely on the material and construction of the device through which electricity flows. For example, a certain length of copper wire, which is a good conductor, has a resistance of 0.000017 ohms. The same length of sulfur, on the other hand, which is actually a very poor conductor, has a resistance of over 2 trillion ohms. So the materials matter. Power. Electrical power is measured in watts, and it is the result of multiplying voltage by current. Watts just measure the capacity of electricity to do work. So let me give you an example that kind of ties all of these four together. You can think of current as a flow of water in a pipe. Current is the amount of water being moved, and more current means more water is flowing. Voltage is the force of pressure pushing the water along. More voltage means the water is pushed harder, and consequently it moves faster through the pipe. That's why cranking up the voltage usually results in more current as well. Now, power is the amount of effort required to do all of this. Think about how much effort it takes to suck up water in a straw. So try that with a 50 millimeter drainage pipe. You'll be lucky to move anything at all. It takes more effort to move more water even if the pressure is the same. And for completeness, resistance would be the size of the pipe. A tiny pipe means you need to push harder to move the same amount of water at the same rate. The water will flow at an easygoing rate, trying to achieve that of a garden hose if there is more voltage and or more current. Trying to achieve a good flow rate with high resistance means you need to add more pressure, and as a result, you'll need to expend more effort to do so. Lastly, power units of measurement. This is relatively straightforward. So I mentioned before that electrical power is measured in watts, and it's the result of multiplying voltage by current. It's just simply measuring the capacity of electricity to do work. A kilowatt represents 1,000 watts. Houses, for example, typically consume less than 100 kilowatts. Megawatts would be 1 million. Mega being million, 1 million watts. Large industries often use kind of under 1 to 5 megawatts. A gigawatt is a billion watts. Giga being billion. All of Alberta has about 16 gigawatts of generating capacity, and a watt hour measures the amount of energy that is produced by electricity over a select period of time. Watt hours are simply the result of multiplying watts by a period of time. This is most commonly going to be discussed in this class. You're going to learn about these a little bit more in the assignment this week, but keep this in mind. Watt being 1, kilowatt 1,000, megawatt a million, gigawatt a billion, and watt hours being a multiple of energy produced by electricity over time.